welcome to this explainer. Today, we're putting on our detective hats to crack the case of rational equations and uncover their hidden restrictions. Seriously, if you've ever looked at an algebraic equation completely loaded with fractions and thought, where do I even begin with this? Well, you're exactly in the right place. We're going to decode this entire process together. Our goal today is to master how to solve rational equations and interpret restrictions, applying those core Algebra 1 standards to not just find an answer, but to really deeply understand the mathematical universe those answers live in.
Okay, so here is our game plan for today. First, the work context challenge. Second, stating excluded values first. Third, clearing denominators with LCD. Fourth, solving and checking candidates. Fifth, extraneous versus excluded values. And finally, number 6, recap and skill transfer.
Let's kick things off with Section 1, the Work Context Challenge, Real-World Rational Math. So let's anchor our algebra in a highly tangible, real-world scenario. I want you to imagine this practical challenge. Two friends are painting a room. Person A can paint the entire room alone in 3 hours. But when Person A and Person B team up, they absolutely crush the job in just 2 hours. So what's the missing piece of information here? It's Person B's individual work rate. How long would it take Person B to paint that room completely alone? To figure this out, we need to translate these times into actionable rates. Now, taking a word problem and structuring it into a rational equation is kind of like putting together a puzzle, and a table is the perfect way to do it. Think about the rates. If Person A takes 3 hours to do one job, well, they complete 1/3 of the job per hour. Person B takes an unknown number of hours, let's call it x, so their rate is 1/x. Working together, they take 2 hours, meaning their combined rate is 1/2 of the job per hour. Since they're working together, we just add their individual rates. So our equation is 1/3 plus 1/x equals 1/2. Moving right along to Section 2, stating excluded values first. Find the rule breakers.
Okay, before we even think about solving that equation we just built, we have to establish the unbreakable rules of our math universe. You know, in algebra, variables represent numbers, but sometimes a variable tries to hide a number that would literally break the fundamental laws of arithmetic. Because division by 0 is strictly undefined. I mean, you simply cannot divide a pizza into 0 slices, right? Any variable value that triggers a 0 in a denominator has to be excluded immediately. So the absolutely crucial point here is that we state right up front that our unknown time, x, cannot be 0. We take our denominator, x, set it to 0, and declare loudly and proudly that x cannot equal 0. And hey, think about the real-world context for a second. It is physically impossible for Person B to paint a room in 0 hours anyway. Setting this boundary before the math even begins ensures we don't accidentally accept a mathematically impossible answer later on.
All right, Section 3, clearing denominators with LCD. Simplify your workspace.
With our rules established, we get to use a pretty powerful mathematical tool to simplify our lives. To clear out those messy fractions entirely, we just find the least common denominator for 3, x, and 2. In this case, that's 6x. Next, using the multiplication property of equality, we multiply every single term on both sides of the equation by 6x. It's actually really satisfying because the denominators cancel out beautifully. 6x divided by 3 leaves 2x. 6x divided by x leaves 6. And 6x divided by 2 leaves 3x. Just like that, our clunky rational equation transforms into a super simple linear equation. 2x plus 6 equals 3x.
But wait, red alert. We have to correct a major misconception right here, right now. Just because you made the fractions vanish from your paper doesn't mean the rule that x cannot be 0 suddenly disappears too. The original equation had an x in the denominator. That restriction is permanently baked into the DNA of the problem. Our shiny new linear equation is just a tool we're using to find candidates. It absolutely does not overwrite the original laws of our math universe.
Which brings us to Section 4, solving and checking candidates. Verify your suspects.
Now that we have a clean equation, it's time to interrogate our suspects. Solving is super straightforward. If we just subtract 2x from both sides of 2x plus 6 equals 3x, we find our candidate is x equals 6. But hold on, we aren't done until we run 2 critical checks. Check 1 is algebraic. We plug 6 back into the original rational equation. Let's see. 1/3 plus 1/6 equals 3/6, which reduces perfectly to 1/2. Boom, the math checks out. Check 2 is contextual. What does that 6 actually mean? Well, with our units, it means person B takes 6 hours to paint the room alone. It makes total logical sense. They're quite a bit slower than person A, which is exactly why working together speeds things up so much to get it done in 2 hours.
Now for Section 5. Extraneous versus excluded values. Know the difference. Sometimes our algebra detective work turns up a suspect that isn't the true solution at all. We really need to distinguish between two types of fake answers. First, we have the excluded candidate. This is a value that was outlawed from the very start because it breaks the original domain, like our x cannot be 0 rule that causes division by 0. On the flip side, we have an extraneous candidate. This is a sneaky little value that actually emerges naturally from the solving process, but when you go to plug it back into the original equation at the very end, it makes the equation mathematically false. Knowing the difference between a pre-existing rule breaker and a process-created imposter is an absolute game-changer in mastering algebra. Finally, Section 6, Recap and Skill Transfer. Apply what you learned. To successfully navigate rational equations every single time, you really just need to remember this blueprint. First, restrict the domain. Stating those excluded values up front is non-negotiable. Second, use the properties of equality to multiply by the LCD, clearing the fractions to give yourself a nice, clean workspace. But remember that the original restrictions remain intact. Third, understand your suspects. Extraneous solutions emerge during the solving process, whereas excluded values are pre-existing rules. And finally, always perform two checks: the algebraic check in the original equation and the contextual check using units to make sure your answer actually makes sense in the real world.
So I'm going to leave you with one final provocative puzzle. We just solved a work rate problem, right? But what if you were looking at cars traveling on a highway, a classic uniform motion problem? So you know the distance, you have some times, and you need to find a missing speed. How will you apply your shiny new math detective skills, restricting the domain, finding an LCD, interrogating candidates, to that completely different real-world scenario? Because the math universe is deeply connected, and the exact same blueprint you learned today is your key to unlocking it. Keep investigating, keep questioning, and I will catch you on the next explainer.